Good afternoon, all the participants. Today we have the pleasure of having Dr. V Baiju with us. Sir is Senior Scientist and Naval Architect, Fishing Technology Division, Central Institute of Fisheries Technology, uh, Kochi. And today the topic of deliberation chosen by our esteemed guest is energy-saving fishing vessels for green fishing. Sir, you're audible as well as visible. Participants have joined. We have around 47 participants which have joined already. Your presentation is also visible. You may start, sir.
Okay, thank you for the introduction. A very good afternoon to all of you. This topic is energy saving fishing vessels for green fishing. If we look at the fisheries census of the fisheries world, the world fishing fleet consists of about 4.56 million fishing vessels in the year as on 2018. Globally, about 37% of the fishing fleet is composed by non-motorized vessels. 68% of all the fishing vessels were reported to be in Asia, followed by Africa, America, Europe, and finally Oceania. Around 40% of the total fleet was less than 12 meter in length, total length. The largest vessels of 24 meter and above made up only about 2% of the total fleet. This is from the FAO statistics. Now, if we look at the design process, design is a spiral process actually. It starts from the owner's requirement. Once the owner gives a requirement, that is which type of fishing, how many days of fishing, what is the capacity of the fish hold, that then we give a preliminary dimension, length, breadth, depth. Then the geometry of the boat is prepared. From there, the stability, these are all stability parts, are calculated preliminary estimate. Then the body, the hull, the body of the boat, the machinery, then the structure of the boat, the power required for propulsion of the boat, the total weight of the boat, the stability of the boat, in case of damage, some flooding, what is the stability range, and finally the cost. If everything is met, all these steps are met, we finalize the design here. Mostly somewhere there will be something which is not matching. Suppose here it is not matching, we go back and correct. Suppose it is not matching here, we go back and correct. So it is a spiral process. So it is called a design spiral. Basically, the type of fishing, length, material, speed, and endurance are given by the owner. The remaining things are given by the designer. Now, design and construction. What are the principles? With fishing vessels, design and construction are based on the rules of classification societies and registering authorities. Classification society means India, we have Indian Register of Shipping, who is giving all the guidelines for the structural design and safety of the boat. We have rules made for all types of marine vehicles, right from small boat, fishing boat, tug, the ships, tankers, everything. Every type of vessel, there is a classification. And once the design and construction are over, once the design is approved, the construction will be taking place. Classification society will be coming and evaluating and correcting wherever there is anything required. After the construction, the stability is tested. Then the registration takes place with the Department of, for fishing boats, it is with the Department of Fish. Others are with the Mercantile Marine Department. So fishing boat registration is with the respective state. If it is Maharashtra, Department of Fisheries, Maharashtra. If it is Andhra Pradesh, the Department of Fisheries, Andhra Pradesh, like that it is, the registration, because this fisheries is a state subject. This ensures, these classification rules ensures the structural and operational safety of the vessel as well as the crew and all items on board. Now, we have to choose a suitable material for construction. There are different types of materials, steel, aluminum, fiberglass, like that. Then the optimum size, the length, the breadth, the depth, the speed, the volume of the vessel, so that the cost is not, operational cost is not very high. Then the class or standard approved raw materials only shall be used for the construction. Class Wi-Fi. Just a moment. I am Wi-Fi and the phone. So the class, main engine, valves, and other machinery are to be approved type. Cooling, freezing generators are to be chosen carefully. Efficient layout of the deck, fishing comfort, maintenance, fuel saving is to be ensured. The position of the willows, the cabin. The willows is the place where the navigation takes place. So we should have a very clear view towards forward, side, and aft. Selection of propulsion and deck machinery. This is very important in case of fuel efficiency. Suitable hygienic fish storage. That is a very important part because ultimately the fish has to be caught at a hygienic condition. It has to be transported to the port, and then only we get the proper value. Then safe and comfortable berth, galley, mess, toilet, etc. Life-saving appliances, fire control appliances, lights and sound signal. This I will come to you. Life-saving appliances is the safety for the safety of the people working on the boat. There are life jacket, life buoy, life raft, etc. Then fire control, because these boats are fitted with engine and diesel and petrol is on that. We have take care of preventive measures for the fire accidents. Then light and sound signals. These are daytime and night signals are there. Then there should be communication facilities with the port or the other boats, other ships nearby. Then the pollution norms are to be, because the global warming is becoming very, very important. Now coming to the design, let us see the design. How this is the basic design, general arrangement drawing. Now this length 22 meter means from here to here. This is the length. Then the breadth 6.5 meter means this is top view. This is the breadth. This is the breadth. And the depth 2.75 meter means from here to here. This main depth to this point. Here to here. That is the dimension. Now we can look at the boat. You see there are insulated storage, refrigerated tank. There is a machinery space. There is a fuel storage. There is a freshwater storage. Then there are other fishing store. And this is the area where the deck opening is there. From here you open and go down and keep the fish in the compartments. And the RSW tank is also there. Then we have the main engine, the generator, and so many machinery here. These are the tanks, as I told you. The steering compartment is here. This is the rudder. There is the propeller. This is the navigation area, the wheelhouse. And there is this deck. We have the accommodation. Then the mess, toilet, everything is there. Now this is a class approved design. These boats are built by Cochin shipyard, Goa shipyard, and all that. This is a private shipyard where the class approval is not there. You can see the difference. There's a lot of difference. There is not much of facilities, and details are not there. This boat is designed by ICAR-CFT for the National Blue Revolution Scheme. Now coming to the types of boats, there are trawlers, gillnetters, purseaners, ringseaners, liners, combination vessels, etc. Now if we see, this is a trawler, this is a gillnetter, this is a ringseaner, this is a purseaner, this is a combination vessel, long length and gillnetting. Now how can we achieve energy efficiency? One is designing fuel efficient hull form. To design a hull form means this shape, body shape, because the boat is moving in water. This body shape determines the efficiency. For that, we can use computational fluid dynamics software, where the total boat can be modeled and the sea conditions can be modeled, and we can simulate the conditions and run the boat. But we can have model testing. Model testing is a small model of the boat is made and it is put in a towing tank. Towing tank is available in the IIT Chennai, IIT Kharagpur, NSTL, Visakhapatnam, and all that, and outside India also. It's a very rare facility and very expensive also. Now, next step is making efficient propulsion system. The engine, the gearbox, the propeller, everything should be very efficient. There should not be any loss of. There should not be any loss of power. Then we have to go for the optimum size. The boat size, the length, breadth, etc. should not be too much. It should be optimum only. Then setting optimum speed of operation. That is very important. If you go for high speed, the fuel consumption will be very high. Following, we go for some operational controls. Unnecessary idling of the engine, etc. should be avoided. Then we can use combination fishing. Instead of one fishing in one boat, we can go for one or two different types of fishing combinations for fishing, which will be saving the cost of operation. Then the bulbous bow, this I will explain later. Then minimize the energy loss from propulsion, engine, the reduction gear, the shaft, etc. Using eco-friendly materials for construction. This is very, very important. Then proper maintenance. Making efficient propulsion system. We can choose a main engine. Just like any automobile, there is an engine, there is a gearbox, there is a shaft, and there will be, instead of tires, it will be a propeller. So main engine power and RPM should be optimum. The reduction ratio should be optimum. The shaft diameter should be optimum. Length of the shaft should be minimum, so that the loss of power is very less. Then in case of a trawler, we put a caught nozzle, which will give more thrust. Now coming to the optimum size. See, optimum size, the length of the boat is this. From here, the forward end to the aft end. Aft means the back. And the beam is on the deck level. We must be at the middle portion. We take the breadth. That is the beam or breadth. Then depth. I told you already. This is the depth. And underwater depth is called the draft. So then we will go for the optimum size of length, breadth, depth, then optimum fish hold volume, optimum size space for engine room accommodation and all other facilities. Then optimum speed of operation. Overspeed will attract higher fuel consumption and operational expense will be very high. And the pollution also will be more. And when we go for another very important problem, important issue that can happen is when we run the engine at a very high speed continuously, the life of the engine also will get reduced because the heat transfer takes place very high extent. Then it gives more, so that in that case the maintenance also will be more for the engine as well as the gearbox. Then the pollution level also will be very high. Now, operational control. We can control the operation by reaching the ground and return. Speed is required for reaching the fishing ground and catch the fish and come back. Another one is minimizing unnecessary idling at harbor and sea. Then cut unnecessary use of gear, generator, fans, lights, etc. Keep logbook making entry to know the daily fuel consumption. That will give us an idea about how it is happening. Now, speed and fuel consumption, what is the relation? There are three types of boats we can take in the displacement boat, which is going like this. Semi-displacement, the forward area will be lifting up, planing, high-speed boats. Now, if you look at these boats will be having a speed of 5 to 7 knots only. So these boats, 5 to 7 knots, 7 knots, this gives only 1 liter for 1 nautical mile. But this boat, just see the difference, 10 knots, it goes at a higher speed, but the fuel consumption is 3 times. This boat also. That is the relation. As we increase the speed, suppose if this boat we try to go at this level or this level, the fuel consumption will be 3 times. Now there are different types of engines: outboard engine, kerosene engine, petrol engine, diesel engine, turbocharged diesel engine. There are different types. Right sizing the installed power. Smaller engines have multiple benefits of lower investment cost, lesser maintenance, and huge reduction in the fuel consumption. Overpowering the vessel is wasteful in terms of energy, as the maximum attainable speed of the vessel depends on the length of the waterline. Even if we unnecessarily, if we increase the engine power very high, the speed will not be there because it has to move in water. The installed power, engine power for a small fishing vessel engaged in a passive fishing method gilleting long line need not exceed 5 to 6 knots per ton of displacement, with 10% increase in the typical conditions. This is a suggestion by Guru Johnson, an expert in the field. In the case of outboard engine, this should be 7.59 HP per ton. That is a rough calculation. The maintenance. The loss of efficiency of a badly maintained engine can be up to 30%. Preventive maintenance including regular cleaning, regular replacement of injectors, oil changes. Just like any other vehicle, we have to keep maintaining the boat and engine. I told you about a hull form. This is a boat which is designed by me using CFD, computational fluid dynamics software, and this is the bulb. So when the boat is moving in the water, there will be waves. This will make another wave, and the bow wave, the other wave will be getting compensated, and the resistance will be less. That is the advantage of this bulbous bow. This is called the bilge keel. This prevents the rolling of the boat. The water will be moving, so the rolling will be reduced. This boat is designed here and constructed Goa shipyard, and this is under IRS class certified. And this has become the model for the Blue Revolution scheme of the government. The facilities, now we have long lining facility, the gill netting winch is there, the aft we have the trawl winch for this boat. These are 3: long lining, trawling, and gill netting. All the 3 combinations are done in one boat. Otherwise, this needs to be done 3 boats. So there is a lot of saving in this. That is the advantage of combination fishing. Now, bulbous bow, as I told you, just reduces the resistance up to 15%, and fuel saving by this is around 8%. 8% fuel saving is a very good thing because when you consider the 20 years life of a boat, 8% in 20 years will be returning a lot of revenue. Now, the vessel technology, how it works. The power is generated by the main engine. Some 27% of the power is given for wave resistance. 18% is going for overcoming the skin friction. 3% goes for overcoming air resistance. The wake and propeller goes for 17%. And ultimately, we get to 35% at the propeller. This propeller is here, the engine is here. This all other waste goes up to 60-65%, and we get to 35% at the propeller for propulsion. Now coming to the fishing, actual fishing, how it happens. Let us see. There is a fish, resource. The boat is somewhere here, goes to the ground, find out the resource and come back. Now, pre-industrial period, there was no engine, no machinery, nothing. So there the sail was used. Human power was also there. We go to the fishing ground and they operate the fishing gear using manpower. In the industrial area, see the engine is used, the ice is there, so many machinery is there. Here, the fuel energy consumption is 100 to 3000 liters of diesel per ton of fish. Every ton of fish was spent this much. Here it was not there much. The fuel use. We have different types of fishing gear, passive gear as well as active gear. Passive gear means you put the gear and you wait there. The fish will be swimming across and get caught. Here, the main part of the fuel consumption is going to the fishing ground and coming back. The fishing does not take much of fuel because the boat is idling there just. When coming to active fishing, you see, the going to the fishing ground, the trolling method is okay. If you go for positioning trolling, see, the going to the ground is taking this much, but searching for the fish is also consuming a lot of fuel here. Most fuel is used for going on and searching fish. Here, coming to trolling is a very active method. Going to the ground is, coming to the ground is this much only, whereas the fishing, actual fishing, consumes a huge quantity of fish. This is according to the FAO calculations. Now let us think about the energy. Now we know how to do the control the energy. Now let us go for different varieties of source of energy. One is petrol. Pre-industrial area, as I told you, it is wind and sail power and human power. Now industrial area period, it is petrol engines, diesel engines, kerosene plus petrol engine, the nuclear fuel, solar, hybrid, diesel electric, LNG, LPG, fuel cell, ammonia, hydrogen. These are the main source of energy used in the marine field. Now let us see which are all applicable for the fishing boats. We can go for petrol outboard motors. Petrol long tail engines are there. Outboard motor is advantage. This can be fitted here, and after the fishing, we can remove and keep it safe. This can also be removed. Coming to diesel engines, these are the most efficient engines for propulsion. We know most of the trucks and buses they are running on diesel engine because there is a fuel efficiency and the power efficiency is very high in this case. Thanks.
Updating.
Oh. So now if you look at this figure, the boat is there, there is an engine, and just behind the engine there is a gearbox, and the gearbox is connected to a shaft. At the end of the shaft, the propeller is there.
Yeah.
So the engine power is generated here, and coming to the propeller here, the propeller rotates, the boat goes forward.
Yes.
And these diesel engines are more suitable for a power range of 30 HP and above, used with a reversible reduction gearbox. The kerosene and petrol combination is there. These are used in the outboard motors. Now, outboard motor is also a standalone unit. There is only, the whole thing is propeller, everything is in one unit. It starts with petrol and runs on kerosene. Runs on kerosene. Start with petrol and runs on kerosene. But the problem is this pollutes the water bodies. It pollutes the water body. The issue is it will damage the environment. Now let us go for the other wind and sail. Before 19th century, almost every ship had been using only the wind power by classic sails and supporting the worldwide trade and logistics in these days. In the 1980s, after the last oil crisis, many kind of modern sail-assisted ships were developed. Now, we'll be hoped to become one of the best solution against carbon dioxide because this is a natural power freely available, no side effects. Let us go for that.
Yes.
Then fishing vessels in many parts are using the advantage is that no fuel, no pollution, no operation cost, no maintenance, no gearbox, nothing, no battery, minimum cost, successful in the traditional sector. in the traditional sector, important. This cannot go to deep sea and stay there for multi days. But all the coastal boats can be converted to this, and no sound pollution also. Fuel cell. The advantage of fuel cell is low emission. The pollution is very less, noise is very less. It's a new technology, not so popular, but it's expensive. So it is not used in fishing vessels. There are alkaline cells are there, proton exchange cells are, phosphoric acid cells are there, different types of cells are there. Let's come to solar power. The first solar fishing boat, this one has been designed and constructed here by CFT. This is the second one. The advantage is, this is also, there is no fuel. The solar panel is here. The solar panel is here also. The solar panel gets charged. Charge is coming to the battery here. Battery drives the electric motor. So again, there is no fuel use. Sun is available. Energy from the sun is available all over the country. Even in the rain, there will be some little charging going on. You need not get 100% sun. Depending upon the intensity of the sun, charging intensity also will vary. There is no carbon emission during operation. There is no sound. The sound is absolutely low. We will not feel that the boat is moving. Solar panel canopy, this protects the people sitting here. Otherwise, the boat will be open. The sun and rain will be coming. The battery is used for solar power. So this, after charging, we can run for 5 to 7 hours continuously without charging. It is highly suitable for inland fishing. And this is actually, you can see catamaran. Two hulls are there, and there is a wide space available on this. This is a 3.6 meter boat. This is an 8 meter boat. Hybrid diesel. These are not used in the fishing vessels. Now the latest technology is trying to use the LNG and LPG. LNG we have used as an experiment for the first time in the country. Our CIFT fishing vessel, this vessel has been converted from diesel to diesel plus LNG dual fuel. This is a LNG storage tank. The LNG is stored at a tank at a temperature of minus 160 degrees. You can imagine the temperature. So that is a slight issue because the storage at this temperature, keeping the storage tank and all that is a difficulty. But there are some advantages, like the cost is less, the pollution is less. Now, which are the most suitable fuel for this fishing? Now we have gone for different types of fuel and fishing methods. For the inland sector, I will say that solar boat is the best because there is no fuel, no pollution, less carbon footprint, no sound pollution, clean FRP surface. Fish doesn't get much of post-mortem decay because clean surface. Thin hull, rolling is very comfortable working, wide area, suitable for shallow waters. Canopy is the protecting sun. And for marine fishing, diesel engines and dual fuel. Diesel fueled engines are having a lot of particulate matter, pollution is there, but efficiency wise, the power wise, diesel engine is the best. Then dual fuel engine have lower NOx, and nowadays the pollution is measured in terms of NOx standards, particulate matter standards. So these are all very important. If you go for dual fuel engine, since some of the diesel is getting replaced by the other LNG, LPG, dual fuel, this NOx and particulate matter emission is less. These are the important things. Thank you.
Thank you, sir. Now, if we have any questions, we may ask. Few people have raised hands, I guess. They can ask question.
Thank you, sir.
Yeah.
Ask
Welcome.
the question if you
Fastly, sir, can you
Doctor
present the vote of
Vansha
thanks
Prang,
to the esteemed
Vansha,
guest?
just a second. Wow. Vansha Prang, TV show. If you have any question, please ask.
Participants, if you have any questions, please write down in chat or you can ask directly to the sir.
Good evening, sir.
Yeah.
Sir, how much cost of the LNG, sir, per kg?
LNG cost is, see, this is, LNG has not been commercialized by Petronet LNG in the country. The
Any
first time, they have given us free for the trials. So we have done a lot of 30 for the trials. Now they are going to give us at a price difference between diesel and this one will be around 20% lower than diesel.
Okay. Sir, whether we are using that CNG, sir, that compressed natural gas also we are trying to using for fishing boat.
No, CNG is not used. CNG is not used. CNG and LNG, the problem is
okay,
the
any
power.
possibilities there in CNG? We are
CNG,
using.
CNG and LNG, the issue is it is not giving sufficient power.
Okay, sir.
Yeah. LPG is little better. CNG has not become so much.
Okay, sir. So small boat we are using now, sir, that CNG, that up to 10 HP, that outboard motors there.
That is LNG and LPG. That is LPG, not CNG.
Okay.
LPG, some places it is used, but it has not become very popular here. The initial that torque is less. That is the issue. Yeah. Right.
Okay, thank you, sir.
Welcome.
Any other question?
Yes, ma'am. Sir, how the bulbous bow self reduce the fuel consumption?
Yeah.
So,
See,
what is the actually real science behind it? Real engineering aspect?
Yeah. Imagine this boat is going in the water. You can see the slide now. The boat is
Sir.
moving in the water.
Sir.
The water, sea is never calm. Sea will always be having some waves. Some waves will be there, like this.
Sir.
Some waves will be there. When this moves, this is the water level. When this moves underwater, this bulb will be producing a wave. There will be another wave here. These waves will get cancelled. So the wave resistance will reduce. The boat is moving in the water. When the waves are coming, it will be hitting and there will be loss of energy. But this bow will produce another wave and these waves will counteract and waves will get dispersed and the wave resistance will be less. So boat will be moving at a higher speed.
Okay, sir. Sir, have you prescribed this design to state governments?
Yeah, this is the base boat for the Prime Minister's Matsya Sampada Yojana now and the Blue Regulation Scheme. Nearly more than 300 boats are under construction and boats are moving also.
Okay. Thank you, sir. Thank you.
Anybody else?
Sir, one more question, sir.
Please.
Be over.
Sir, these solar boats, have you prescribed to state government, sir?
Yeah, we have this boat is given to Kerala government. They have there is a reservoir, freshwater reservoir. This is the trials which I did for I am sitting here. We are doing the trial fishing on this. After that, the boat is given to Malambura. There is a freshwater reservoir where the fish farming is also taking place, and the fisheries department is using this boat there. This boat is slightly bigger and it has been given to an aqua tourism center there in Kerala. It is again government organization society. And this boat is running there daily for the last 5 years now. So it is giving a lot of publicity and the government can decide on taking this or this model and give it to public. We have already given it.
Okay, sir. Thank you, sir.
Yeah.
Thank you.
Welcome.
Anyone else? I think if there are no questions, we can consider the session to be over. If there are no questions, do you have any further questions? Please ask. Otherwise, we can consider the session to be over. Sir, I think there are no further questions.
Okay, fine.
On behalf of the participants and the organizing committee, we'd want to extend our gratitude to you, sir, for being with us, for sharing this lovely presentation with us and resolving the questions and queries of our participants. On their behalf, I express our heartfelt gratitude to you, sir. Thank you very much. being with us.
Thank
Thank you.
you. Thank you. Thank you. Welcome. Thank you.